Good evening, welcome back. So we'll be starting our first chapter from our textbook. This is what our textbook looks like. And our textbook has 20 or so chapters. We'll be actually spending a couple of lectures on Chapter 1. Chapter 1 is all about Introduction to Computers and Programming Languages. This is an easier chapter, and in fact, there are a lot of terms in this chapter. You're probably very familiar from other classes. You're probably familiar from your experience from work. But some of the terms will be slightly newer, and especially when it comes to programming languages, especially when we deal with C++ as a language which we are going to use in our class. Anybody can tell me what software we are going to use in our classroom for C++ programming? It's Visual Studio. Visual Studio, who is the vendor? Microsoft. So Microsoft Visual Studio is the program we'll be using. For Mac users, if you are watching this video online, you can use Xcode. It's recommended. There are other possibilities as well. If you are more comfortable, any other recommendation do you guys have? If you want to use Visual Studio on MacBook, what would you do other than Xcode?
Download Windows like Parallel.
So you can actually partition. And in that case, you actually have install a separate operating system, and you can install Visual Studio as well for those people who are a little bit more comfortable with the operating systems. All right, so what about this chapter? So this chapter, which is, as you can see right here, Introduction to Computers and C++ Programming, or Programming Languages in general in this chapter. But our focus will be on C++ mostly. So some of the objectives in this chapter, we'll be discussing computer systems, programming and problem solving, introduction to C++, testing and debugging. And some of these concepts will be discussed in the first half of our lecture, and some of the concepts we'll be discussing after the break. So you'll probably have 2 lectures, and I'll record both lectures. And you might have to take all the conceptual discussions in the first video. And in the second video, you can actually see the Visual Studio and hands-on exercises and demo. Now, when it comes to a computer program, that's why we are here, just to become computer developers, or we call them coders or developers. There are 2 types of software out there, 2 types of general-purpose software, and then we can actually highlight the definitions of those 2 software. Then we can get to more specific kind of software. So what are the 2 major types of software? So we know we have application software. Can somebody give me an example of an application software?
Word.
So Word, Excel, Photoshop, all the games you play, browsers, all these are applications.
All these icons on my phone.
Absolutely, all these apps on your phone. What is the purpose of an app or application? Why do you have these apps on your phone or on your desktop?
Solve a problem.
To solve a problem. Absolutely, that's why you have the program. A problem could be a simple problem, such as BMI calculator, or it could be convert your US dollars into euros. So that could be a simple program, 1 or 2 lines of code, and you can actually develop that kind of, and you probably have noticed these kind of programs on the web. You go somewhere and it says calculate your BMI, body mass index, and you plug in your height and weight, and it actually spits out the results. That kind of program you can actually develop very, very quickly in Java or C++ or any one of these programming languages. So that's one type of software. The second type of software is called system software. So system software are not specific for one purpose. They are more generic for a variety of purposes. Their purpose is to solve different types of problems. For example, they manage all the resources on your computer system, such as you want to run a certain software, you want to use some peripheral devices, you want to print something. Those are system software. Can somebody name one system software? Windows. How about on your smartphone? What kind of system software do you have installed? Android or iOS? So those are system software. System software are more complex. They are more harder to write, because if you want to develop an app, you can develop an app in probably 15-20 minutes. A simple app can be developed. For system software, they are more complex. There are other categories of system software as well, such as utility programs, device drivers, and some authors and some people also place programming languages under system software as well. right? So system software, we have operating systems, utility programs, device drivers, and probably programming languages. On the other hand, we have application software such as Word, Excel, and we are going to develop our own applications in this class. In fact, tonight we'll be developing our first application. Yeah.
So a program like SQL Server, is that an app or a system?
So that's a database. So if you are working with a database, probably all the apps based on that particular database
But
will.
I'm talking about the software
It
itself.
probably will be under system software.
System,
Yeah.
but not Access.
Access will be
No, a database.
Access will be an application. Yeah. Access is a much smaller database management system, but there are some of the big ones like Oracle, and these are much larger and complex. There are some other programs such as SAP or PeopleSoft. These are very large ERP systems, enterprise resource planning system. All right, so after we finish this chapter or tonight, you should have pretty good understanding. You stand somewhere, you go for an interview, they ask you, you know what, you have taken an introduction to computer science class, tell us what is a computer program. You should be able to define in layman terms. You should be able to tell a program is what? Program is set of instructions. So you say, well, I still don't understand what does it mean by set of instructions. If I ask you, what is your program for or wedding plan steps? What steps you are taking for your wedding? You'll say, I'm going to do step 1, step 2, step 3. I say, okay, how do you cook certain dish? You'll say, in my recipe, I will do this, 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 and I need these ingredients. That's a program. So program requires specific instructions and certain sequence. You cannot mess up the sequence. So that's exactly what the computer program is. It's a set of instructions in a specific sequence. And the computer will follow those instructions in order to produce desired results. Now, is a program, computer program, just like data? Is the other name for a program is data? Or these are the two different things? Program and data, they are two separate entities. They're two separate things. What do you think in a large organization, large business organization such as Bank of America or Costco, what are the 5 major components under MIS or information systems? If they have an information system, what are the 5 major components? They need to have hardware. You guys agree? Like these kind of computers and monitors. They need software, which are basically programs. What else do they need in order to run a successful information system? Hardware, software, data. Data, absolutely. They need data. So hardware, software, data. They need, that will fall under hardware. Storage will be under hardware. What else do they need? Do they need people to run those systems? Yeah. So they need people. Hardware, software, data, people. There's one other piece is needed. They need some kind of business practices, some kind of guidelines, some kind of business protocols, some kind of standards they have developed in many years. How do you refund this item at Costco? How do you make a purchase? How do you print a transaction receipt? All those things. So these are the 5 components of in a large organization. Typically, you'll see hardware, software, people, data, and business rules. Now, out of those 5 components, what do you think, which one is the most important one? So you're saying hardware?
People.
You're saying people? Protocol, that's business standards. How about you guys here? So as you can see, we are disagreeing. So of course, all 5 are necessary, but if you remove one of them, it will be very difficult to replace. Can you easily replace people? You let go of developer. Can you find an alternate developer? You can call somebody and outsource somewhere else. You can hire somebody. There are Salesforce.com kind of companies out there. You can take the entire IT system and they can actually have those people. Same thing with hardware. You can, if this particular item doesn't work, you can easily replace it. However, if the data is missing, let's say you go to bank and none of the data exists. It's not there anymore. So imagine that will be run on bank. Have you heard the term run on bank? It happened in 2007 and 2008 We had run on bank in Europe and in our country because of the recession. Run on bank means people literally run towards the bank because they panic, because the bank has no more money. There's no more money to be given to their customers, which belong to the customers. So what I'm trying to say is the data is very key here. So in fact, you're developing these programs to do what? To take the data, which is an input, bring it to your processor, process it, and to produce useful information. So data will be processed by using some kind of program. So we will be developing those programs. So our job is to take the data, process it, scrub it, clean it, massage it, and produce useful information based on the business rules, right? So that's a good way of thinking when you talk about computer program and set of instructions. And it's a collection of programs used by different types of, like you have translators and managers and all these different types of, by different types of systems. So there are 3 types of categories discussed in your book. And some textbooks, they have 5 categories. So they have all the way from supercomputers to handheld computers. In between, they have mainframes, they have servers and clients, and they have desktop computers, or we call them personal computers. So here you see personal computers. What kind of computers they come to your mind when you talk about personal computers? We have desktops, laptops, tablets. Some authors, some textbooks, they also place your smartphones under here because they're computers. You can access the browser. You can actually access many of the major applications. You can do banking. You can do all sorts of fun things. Then your workstations, we used to call them dumb machines or dumb terminals. So workstations, typically when you go to a teller, they might not have ability to store the data on a floppy diskette at that time, or a USB or some kind of hard drive. It was just a terminal connected to the mainframe computer. Mainframe computer is a larger computer somewhere else, maybe in Chicago, maybe in New Jersey, maybe somewhere else, maybe in San Francisco, and the terminal is only accessing the data for their customers. So that will be larger and more powerful than a PC. And these days, we actually have something called client and server environment. So server will serve, if not hundreds, could be thousands of computers can be served by a server to the clients. In fact, these are the clients right now in our room. These are the clients. These are the clients served by a server. So server is in a secure location. Sometimes it's in the same room, in a locked room. Sometimes it's a different location in the same, on the same floor or same building. So a server can serve hundreds or thousands of clients. So these are clients. In fact, there are numbers assigned to each one of these clients. So that's how they can actually control these clients from remote locations. So mainframe computers are used by larger organizations such as banks, insurance companies, airline industry companies. And there's another category which is not highlighted here, which is supercomputers. Supercomputers are used by fewer organizations for weather forecasting, for simulation, for defense industry, and research and medical kind of areas. So when you have these computers connected, what do we call it? Network. So when you're connected with your colleagues here, so you have a network. What kind of benefits do you get from network? Share data and information, sure. Share all the resources. Like if you have power, you can carpool. Here, if you have one printer, all these clients can access that printer. So any other benefits come to your mind? So not only share printers and information.
If there's a central security like a server,
absolutely,
then you have security for the entire network.
Absolutely, absolutely.
If you do it right.
You can actually secure somebody who is a data security specialist. They can secure your data. They can ensure the outsiders, the intruders, hackers, we also call them crackers, do not crack the system. So they can actually ensure remotely by securing the server, because they will be attacking on the server. They will not be individually attacking on these workstations, because most of the data might reside on the server itself. So that's an advantage of network. And in this class, we don't spend too much time on networks, but if you are if you're taking Business 150 class or similar CMPR 100 class, you'll be spending entire chapter on networks and security and different types of ways to handle it. So your computer can have five components, and those components are input, output, as I've shown you here, like your keyboard, that could be an input. Any other device comes to your mind about input? Mice, absolutely, mice.
The camera?
Yeah, you could be scanner, camera.
Scanner.
Yeah. How about output?
Monitors.
Monitors, printers, yeah. So
Yeah.
right, speakers, yeah. What about the processing? So processing will happen in your CPU. CPU stands for Central Processing Unit. This will be in your exam. So there will be a couple of questions directly from these terms. So you need to be familiar. These components, what is an input, what is an output. And inside the CPU, it's not discussed in a lot of detail in our book, but if you look inside the CPU, it has additional components called control unit, arithmetic logic unit, registers, L1 cache, L2 cache, and sometimes L3 and L4 cache is outside. So let's talk about these additional components just for a few seconds. The control unit is the main manager of the central processing unit. Every instruction comes to CPU. Control unit delegates that particular instruction to some other component. If it needs to go to the RAM, control unit will send it to the RAM. RAM is your primary memory. It's a volatile memory. It's the memory which is immediately available. These days, RAM is much larger. RAM used to be very small about 20 years ago. These days, what is the typical size for your random access memory?
16.
So you can have 8, 16, 32, very large RAMs. Used to be very, very, very small. When I was learning computers, I was a kid, the RAM size was 256 kilobyte. You wouldn't even understand what I'm talking about. Really, really, really small RAM. Anything you open, any file, any picture needs to open in RAM in ones and zeros. So bigger RAM means more programs you can open, more data you can process. So these days RAM sizes are pretty large because our programs are more complex and large. So notice that, I want you to really notice that RAM is outside of the CPU. RAM is not inside of the CPU. So if you really look at it, so processor is a small component, small chip. The RAM is sitting outside. Some of you probably know how to build computers. You must have upgraded your RAM from smaller RAM to larger RAM. It's very easy. You plug in, plug out, and plug in. It's really easy. We used to do that a few years ago. These days, every couple of years, our institution, they give us new computers, so we don't need to upgrade our RAMs. But when I used to have my own personal computer, I used to upgrade my RAM from a smaller size to larger size because otherwise your computer will run much slower. All right, so what is L1 cache and L2 cache? Cache is a smaller memory, maybe 1 megabyte, maybe 4 megabyte, maybe 8 megabyte, depending upon what type of computer processor you're purchasing. And when you're purchasing, it will tell you in the specification what type of cache memory is in the processor. So that processor cache memory will make your processor run a little faster because it doesn't need to go outside to store small piece of information or data. It can store inside the processor, which is very readily available and easily accessible. So bigger cache memory means faster the processor is going to run. So when you are purchasing your personal computer, pay attention to cache memory as well.
What did you say the types were? A something, A1 or A2 or L1? I didn't hear the letters. You said there are two types of cache memory.
Oh, L1, L2.
L1. What does that stand for?
Not too sure.
It's just
Yeah. Yeah, I'm not too sure. We can figure it out. Let me see if I can find out what does L1 cache means. So L1 cache, level 1 cache, there you go. A memory bank built into the CPU chip, also known as primary cache. These days, you will find L1 and L2 cache inside the processor. And if you need more cache memory, so the more cache memory will be outside, might be a separate chip by itself here. That could be L3 cache. So before the central processing unit goes to the RAM, it's going to say, OK, let me see if I can store the data in L1 or L2 or L3 or L4 cache, because it's much faster as compared to the RAM. Now, let me also tell you, but 15 years ago, our RAM size was much smaller, and if you open 4, 5, 6 programs, what would happen? You would have the blue screen of death. That's the terms we used to use, which means that the computer will crash because the RAM is full and it doesn't know what to do. Now, these days, what happens if you fill up your RAM? You open 50 programs, 50 browsers. So it's not going to crash these days. It's going to do something else.
The app will say like processor something unavailable, like the application will stop working.
OK, yeah, that's a possibility.
It'll use the hard drive as temporary cache.
Absolutely, absolutely. So it actually goes to the hard drive because hard drive is very large, maybe 1 terabyte, maybe half a terabyte, maybe 2, 3 terabytes these days. And it's going to use the hard drive as memory. And it's called virtual memory. And it's going to show a message that I'm going to use your hard drive as your virtual memory. Most of you will probably never see that message these days because your memories are much larger and you're not going to open 50, 60 programs all at the same time. But if you have a very complex database, very large simulation we are running, probably you will see that kind of message. In some organizational settings, you will have that kind of program. OK, so let's continue. So we have some understanding what the memory looks like. And we call it main memory. It's volatile. Volatile means it needs source of energy all the time, source of electricity. As soon as you turn off your computer, everything will be wiped out. The secondary memory, or we should not call it memory, it's a secondary storage. That's your hard drive, your CD. Or, you used to have floppy diskettes. Even before that, tapes. My first program I stored on a tape. So, Juan, did you store your programs on punch cards? Did you store on a punch card?
No.
No, you never used punch cards. Yeah.
Oh, this close.
Yeah, yeah. So I actually was not in that era as well. When I started using computers, it was either tapes or the bigger floppies. They were like 5-inch floppies. Then we moved on to other types of storage, like 3.5-inch floppies, much smaller. They were the harder jackets. In fact, when I was collecting homework assignments, I used to carry 200, 250 floppy diskettes in my briefcase every single week. Take them home, put them, and many of them did not work. They had a virus, they couldn't work, they were corrupted. So it was a big, and you might ask, why didn't they upload on the cloud? They didn't exist. There was no such thing as cloud. How come they didn't put it on your learning management system like Moodle? Didn't exist. There was no such thing.
We didn't even have PCs when I was going. It was all mainframes, so who knows where the programs are being stored.
Right. So it was more like a tape, like a much larger tape.
I remember the hard drives were huge.
Right. Yeah, it was like a suitcase. Yeah, very large. So do you think, how many of you own a terabyte of storage? Most of you. But 10 years ago, I used to claim that one day consumers will own their own terabyte. 1 terabyte used to be $10,000. And now a terabyte is 2 or 3 terabyte from Walmart, Costco, or one of these stores. You can get it $60, $70. Very inexpensive, extremely inexpensive. But imagine now we have petabyte and yottabyte and exabyte. Probably 10 years from now, we'll not be talking about terabyte because terabyte might be too small because things will be in 3-dimensional. We are talking about 8K. People actually have the 8K monitors and 8K videos, so they need much more storage as well. All right, so we are okay with these components. So main memory, which is contains zeros and ones, and I think briefly showed you. If you take a character and how you can store in a byte. Last Tuesday I showed you. So computers only understand one language. It's called binary language. So when somebody talks to you, and who have not taken a class, how would you define the computers and technologies and all these different devices? They only understand ones and zeros. One means the electricity is flowing, zero is electricity is not flowing. So that's how the data is stored. On the other hand, humans, they do not use digital. We don't talk digitally. We talk analog. So my conversation, when you hear my sound, is like this. So this is 1, 1, 1. This is 0, 1, 0, 1. This is 1, 0, and so on and so forth. Inside your computer, everything is digital. So that's your PC. So that's your 1, 1, 1, 0, 0, and so on and so forth. Now, of course, when I talk to the computer, these days we have things like Alexa or Echo and these kind of devices. You can talk to them. Or you have Siri if you have an iPhone. You have Cortana if you have Microsoft technology. They also have Assistant. So how do you convert your analog signal into digital signal? You have a device here installed on your computer. Used to be that you had to buy separately. Now all the computers, they come with the device. Anybody knows what do we call this device? So this is our modem. So your modem takes this signal and modulates. MO for modulates and DEM for demodulate. So basically converts your analog signal into digital and digital signal into analog signal. So that's how we get the word modem. So in fact, do you foresee that in the next few years, probably I would say 5 years or less, you will be able to talk to your home? Do you think we have homes like that? You walk in, you talk to your fridge? Yeah. You talk to your garage? Yeah. In fact, we have those technologies that are a little expensive right now. In fact, I know some people personally, when you go to them, they want to show off their home. They want to show off. They say, I'm going to talk to my home. I'm going to talk to my lights. And that's under IoTs. I think I briefly talked about IoT. So if you're under IoTs, anybody knows what IoT stands for? Internet of Things. Big deal. Very big area. So which means that every single device will be connected to the web. So either securely or not secured, but it will be connected. Your cars, your garages, your fridge, your microwave oven, everything will be connected, your entire home. These days you must have a thermostat. They are connected on the cloud, and all these things will be connected. And I don't foresee that it's going to be 10 years, probably less, 4 or 5 years, and you'll be able to talk. In fact, many of these vehicles, the electric vehicles, anybody owns an electric vehicle? So that's the new trend that the goal is by, I think, 2050, state of California wants to replace most of the combustion engines to electric vehicles. Electric vehicles will be the leading vehicles. And we are still the leader in the world. We have the most of the electric vehicles in the world in state of California. So in electric vehicles, imagine you can talk to your car. And you can sit around. You don't need to drive. And it will be available to you in next couple of years. GM and many other major players, they will, including some of the Japanese companies as well, they will make these vehicles available in a very, very near future. Yeah.
What's going to happen to petroleum companies?
So they have to adapt. You know, we have a new president in our country because some people, they were very upset. We lost our jobs because Mexicans took our jobs and immigrants took our jobs and Muslims took our jobs, and they were very upset. So Chinese took our jobs. All the manufacturing is happening in China, and Canada took our jobs because of NAFTA, and they were complaining. So there was so much anger in the society. They brought the biggest, strangest person. I don't want to say I'm recording, but and guess what? That's absolutely absurd. That's not really true. That's not what happened. The technology took their jobs. And a lot of people are still sleeping, just like they don't want to wake up. Those mining jobs will never come back. Those oil and gas jobs will very difficult to come back. Because the trend we have, the trend is unbelievable. You cannot stop the trend. Now, I'm not talking about only solar industry, but a lot of other things. fracking started happening, and all these gas companies, they started extracting gas. So a lot of petroleum companies, they couldn't compete. A lot of other miners, coal miners, there's no way they can compete. So most of these refineries or whatever, the coal mines, they were shut down. Same thing with manufacturing. In 50s and 60s, a person would be hired by GM or one of the other major competitor, and they would retire after 40 years. It cannot happen anymore because before we needed 26 people to manufacture $1 million for merchandise. 26 people for $1 million worth of merchandise in a factory. These days we need 6 people. 6 people. And in some industries, you just need one person to produce 1 million worth of merchandise. So how you're going to give jobs to 25 people who do not have jobs? So it has nothing to do with blaming other people. It's just the whole economy has changed. It has shifted, completely shifted. So somebody who promised that I'm going to bring all these jobs back, I'm going to make a wall, it's not really possible. You have to blame the technology. There's no way you can stop the technology. And you'll see what I'm talking about. You'll see in 2 years, in 4 years, in 6 years, you will see there's no way you can reverse it. The only way you can compete, you have to train yourself. You have to be more competitive. How come all these high-end jobs, you don't believe me, go to San Jose, go to Oakland, go to San Francisco. Who's running all these major information systems? You'll see more than 50%, about 60% are non-American born people working in these industries, on average making $150,000. So we are missing big time. Big opportunities are there, but we are just taking a nap. Not us, but some other individuals are not willing to enhance their skill set, move on to the other industries where we have very high potential. There are 50, 60,000 jobs just in cybersecurity. There are hundreds of thousands of jobs available if you go to Indeed.com, Monster.com, any one of those areas, but most of those jobs require different kind of skill set. So we have a transition from blue-collar jobs to white-collar jobs. And if you go back 200 years ago, we were farming people, right? From farming, one day we decided we are going to become industrial nation. We became industrial nation. Then we said, okay, you know what? A lot of other smaller countries like Indonesia and Malaysia and South Korea, they can do the similar things. Taiwan, we can send these kind of jobs, of industrialized jobs, Vietnam, and we can send it to those countries. We can become service-oriented industry. And we become service-oriented industry. Then we decided, you know what, that's not enough. Now we are going to become information-driven industry. So currently we are in that era. A lot of people are still thinking we are industrial nation. We are not. We cannot compete in solar cell panels. Doesn't matter how much bans. We had a ban last month. And high tax was added. We cannot compete in steel mills because the way China can produce steel, there's no way we can compete. So we actually have to enhance our own skill set. The jobs are there, but not the jobs we are looking for. Daisy, your comment?
I'm just wondering, what kind of jobs are going away in the upcoming years?
So just to give you an idea, do we have a lot of drivers in our nation? Truck drivers, all these jobs will be lost. All these jobs will be lost. We're talking millions of people will be losing their jobs. So who's going to replace their jobs? There are trucks, already Uber, FedEx, UPS, they are working on, and they are actually on the road, their driverless trucks. They already have them. They do not cause delays, they do not cause any accidents, and they are more productive in driverless trucks. Same thing with all these Uber drivers. This is called a gig economy. We have gig economy. Some of you probably drive an Uber or Lyft. Those jobs will be lost as well. Already Uber has many places running these driverless cars. But because they are not 100% sure, so they are not fully available, but according to their announcements, into 2020 or 2021, these kind of vehicles will be available, which is coming like a flood or whatever storm. It's right there. So if you want to close your eyes and say it's not happening, it's going to happen. All the jobs in tellers, cashiers, those will be lost. I hardly talk to a teller and cashier. Doesn't matter, I go. Only in Costco I have no other choice because there are no automated machines in Costco. But in Walmart, in Target, in other places, you don't need to talk to anyone. I don't even talk to anybody at the airport. You have kiosks at the airport. You have robots in San Jose and Oakland airport. You want directions, you want change your flight, there's a robot walking around. You use the chest of the robot or talk to the robot and you can change your flight. So these things are already here. It's just that we are not ready to embrace these kind of technologies. I'm going to move on, otherwise I get more emotional and you'll see my tears. So these bytes, we understand these bytes, they allow us to store how many characters in one byte? This will be a good exam question. One byte stores one character. How many bits in a byte? 8 bits. So bits can be turned on or off. What happens when you turn it on? What's the value of the bit? 1. And when you turn it off, it's 0. So when you look at the byte, which I showed you last time, they have assigned values to those bits. So some data is too large for a single byte. Most integer real numbers are too large. So if you have a very large number, what do? Address refers to the first byte. Next few consecutive bytes can store additional data. So if your data is very large, so what do? So you can point towards the address, and C++ allows you to do that. You can actually, I'm going to show you, you can see the addresses of your each byte, addresses of your variables, and then the rest of the data can be stored consecutively. In fact, the ASCII, I talked about ASCII last time. There are 3 storage standards. ASCII is one of them. There's ASCII, and there's Unicode. So ASCII is American Standard Code for Information Interchange. That's one of the standards most of our computers use. IBM uses its own standard called ASCII. Something like extended binary code, decimal information code or something like that. You can figure it out. Book actually sometimes highlights it. Now we actually have moved on to Unicode. Most of the organizations, they are using Unicode. Unicode doesn't use 1 byte. Unicode uses 2 bytes. Because if you have 1 byte has 8 bits, the maximum number of characters you can store is 256 in 1 byte. So 1 byte is equal to maximum of 256 characters. But if you have 2 bytes, which means 2 to the power 16, you can store up to 65,536 different characters. So Unicode uses 2 bytes. So this actually has the higher potential. In fact, every single human language ever existed will be available in Unicode. Not possible in ASCII and ASCII. In fact, the developers of Unicode, they have already converted all the major languages into Unicode. So if you go to unicode.org, you can find core charts, and these are the languages they have been converted already. So all these, for example, if you just pick one, you can pick any language you want. You can see what is their conversion for specific characters in that language. This is Arabic language. So you can see, and there's a, it's not very clear from afar, but you can see a hexadecimal format value assigned to each one of those characters in that respective language. If you want to go to Vietnamese or you want to go to Cambodian, those languages, you will find them here, some of these here. And what do you call Vietnamese language? That's I know this is Cambodian. So you can see all these characters. You have the ability to store in 2 bytes in Unicode. So ultimately, I believe that Unicode will become a standard, universal standard for storing data. Okay. So A can be stored in a byte, which means 01000001, which means 64-bit and 1 bit, 65. A has a value in ASCII chart of 65.
Question.
Yeah.
Are all the ASCII codes 1-to-1 for Unicode? Like the ASCII code for A, is it the same as the ASCII?
I don't think so. I don't think so. It's a completely different standard. Yeah, completely different standard. But
I know there's something that's a superset of the ASCII code. I don't
yeah,
know
it's possible they might have taken some of the characters from the keyboard we have, like A65 and this and
Right,
all these.
yeah, that's what I'm
So
saying.
probably they might have embraced those standards.
I think
Yeah,
there is something.
probably. So we know A actually has a value of 65 in an ASCII chart, and 65 can be represented in binary code in this format. So how does the computer know the meaning of this? Well, there is something called your CPU. CPU gets the instructions from the operating system. Operating system says, whenever you see something of this format, then I'm going to display a strange looking character on the screen, or I'm going to process that character. So that character could be in uppercase A. So the instructions come from the operating system, but the central processing unit, or the brain of the computer, manages those resources. So this is called the interpretation of the how the characters will be converted into specific format. Well, we don't really have to be concerned about these particular conversions, not that much, not in that detail, until and unless you are writing assembly code and you need to know the specific locations. In our C++ program, I'll show you what the memory locations look like, but we are not going to write in that lower level detail. So reason as if memory locations contain letters and numbers rather than zeros and ones. So we are not going to worry about zeros and ones. We just need to know what is the name of the variable I declared, like employee ID, and how do I access the employee ID? How do I manage it? How do I modify it? That's what our concern is. All right, we know what the secondary storage is. Secondary storage is your permanent storage. It's called non-volatile storage, typically your hard drive. I don't know why they have the floppy disk here. So looks like this author was taking a nap. So nobody uses. Do you see floppy anywhere in any one of these computers? In fact, if you just recently bought a computer, they do not even have your CD players. No CD players anymore. You have to purchase separately. So CD players are taking the last breath. CD players, they will gradually disappear. Although there's a lot of entertainment-related media on CDs, but as far as our computer programs are concerned, or and accessing your data through CDs is becoming obsolete. Yeah.
Are they still making cars with CD players?
Yeah, you can purchase them. Yeah, you can buy from Amazon or some of the other special.
Cars.
Oh yes, most of the cars they will continue to make another maybe 10, 15 years.
Oh, okay.
Yeah, in fact, you can buy a car with the audio cassette still. Yeah, because the life of these legacy systems lives much longer in cars. The reason is you have collection of CDs and you are, let's say, 30 years old. You want to have that car for at least 10, 15 years. And now you're 45, all of your data will be lost. So that's why the car manufacturer, they continue to support these legacy systems for many years. So I remember that the last car I sold, it had the audio cassette. And now my cars will have, and in fact the new cars will still have CDs. Now you might have noticed that they are moving into other types of accessibility for other technologies as well, MP3 players and other types of, right, and USB ports, so you can connect other devices as well. So these are the CDs, so CDs and DVDs, and there used to be so many different standards. CD-ROM, that's what most of us we accessed. CDR, recordable. CDR, rewritable. So it's amazing that how confusing it was 10 years ago. Sometimes you have a CD, it doesn't work on this particular player, and vice versa. So it was kind of confusing. So, but now these are actually not readily available these days. But hard disk, that's what we have readily available on our computers. So we know what the random access memory is, and sequential access is data is generally found by searching through other items first, more common in secondary memory. The random access memory means that the computer program or your control central processing unit is going to store the data randomly. Wherever it finds the location, it's going to store it in that location. So we talked about CPU. CPU stands for central processing unit. This is what it looks like. And it can do a variety of things. Anybody knows what ALU stands for? I had mentioned it. Arithmetic logic unit. So what do you think, what is the use of ALU? So calculations.
Adding, subtracting, dividing,
Yes,
shifting, a bunch of
absolutely. Comparing logical decision for things like, let's say you have the data comes in 2 plus 2. So control unit itself is a manager. It's going to tell ALU, you know what, I'm going to give you some data to work on. Why don't you work on it? If it's 2 plus 2, ALU is going to say, okay, I have the data, the answer available. It will be stored in L1 cache right there. If the data is very large, let's say you're using some kind of Excel, it's going to send it to the random access memory, and it will store there. So, and store means temporary, it will be held in that area.
What does it do then?
So that's Intel and
How does it know if there are files to that? How does it know to send it to RAM?
so those are the operating system. This is the purpose of the operating system. So operating system provides those kind of guidelines, because the processor itself is just basically a bunch of chips, circuitry board. So
Every component has their function.
they have their function, and the operating system tells them what to do. So that's why you can count all the major operating system on your fingers. If I want to count all the applications in the world, I can't. There are millions, if not hundreds and thousands of millions. You cannot count. There are so many of them. On the other hand, if you want to count how many major operating systems are there, how many major operating systems you have on your smartphone? Name. You have Android, yeah, iOS. Can you name the third one? Windows Phone. There's another one. It has about 2%, less than 2% market share in the world. That's it. We are stuck. There are a couple of other ones. Remember, we had BlackBerry.
Well, there's some new ones that
Yeah.
are coming out of China and maybe India.
Then HTC, and there are a couple of others. They used also Android.
But the Android is based on Linux. So
Correct, it
it's
is.
not a new one.
Correct,
Well, but
it is.
for phones.
It is, yeah. So if you look at Unix was developed by AT&T by developers like hobbyists, and from there many other operating systems emerged. Solaris, Linux, you mentioned Android, many of the other operating systems actually. It's called open source, and which means you can modify it. It's free. You can download a free copy. On the other hand, some of the commercial operating systems such as Windows. Can you name another commercial operating system? Or the one we use for Macs, or DOS used to be the original operating system.
Wasn't Linux proprietary? I mean, Unix proprietary to Bell Labs or?
They actually made it available.
They made it open source.
Mm-hmm, yeah. In fact, many of the major players, they make it available, so it has a higher market value. You know, Elon Musk from Tesla, he made all the battery specification. He said, I'm going to make it open and available so other competitors can make better batteries. And you'll say, you're going to lose billions of dollars. It's possible somebody else will make a better battery. But at the same time, imagine if they find a cheaper battery, his Tesla will be cheaper. He's going to sell more Tesla. And one of the Tesla is already in space, or he at least tried to send. Now, which company is bigger? Let me ask you. General Motors or Tesla? General Motors, right? General Motors makes like how many cars in a year? Can somebody type? Can you Google on it? So let's find out how many cars a year in 2017 General Motors manufactured.
Going back to the operating system,
Yeah.
there's two important operating systems that are semi-important, which is Chrome OS and Firefox OS as well that are out there.
Yeah, absolutely, I agree. So, anybody has that number?
Whilst everyone's Googling it, for the No.
Yeah.
For the RAM, it takes longer to pull information from the RAM. Is that because it's randomly organized?
No, they have something.
Okay.
Yeah, it is because the data where it's stored, it has an address assigned to it. So there is a directory which tells it where the particular value is stored. So it can use the data and it can access it. So on the other hand, if you have L1 cache, it's much closer, it's faster. But you can store a lot of data in L1 cache. So somebody said something.
2016, almost 8 million.
8 million. So I was thinking about 10 million cars. How many cars were manufactured by Tesla in 2017?
2016 says 12,000 or 100.
I'm sorry?
12,000 or 100.
12,000, right? So now 8 million. I'm going to just really scare you here, guys. 8 million were by GM, 12,000 by Tesla. Tesla has higher market value than General Motors. So I'm going to repeat what I just said because this is a crazy statement I'm making. The market capitalization of Tesla overcame General Motors, which is absolutely the most stupid thing you will ever hear. This is how the capitalist system works. Tesla doesn't even make even 1% what General Motors does. But people are thinking Tesla has the future, so they have invested hundreds of billions in Tesla. How much is one stock for Tesla? So can somebody look at the stock value of Tesla?
$323.
And can you look at the stock value of General Motors, GM?
It's $150 or something.
$41. So if you look at, okay, check one more thing. The stock capitalization of Tesla, total stocks outstanding for Tesla. It's crazy, because this is what the drives the anticipation, because people anticipate. And this happened with Bitcoin, the cryptocurrency as well, just very recently.
254.4 billion?
Yeah, 254 billion.
54.4
Yeah.
for Tesla. Yeah.
So 250 billion.
The bubbles.
Absolutely crazy. So what was the cryptocurrency value a couple of months ago? It was 20,000.
Yeah.
Now I think a couple of days ago it was 8,000. So it goes up and down like in thousands. So if you don't understand what I'm talking about, if you owned, let's say, $1,000 worth of cryptocurrency 5-6 years ago when it started, you would have made $1 million. And a lot of people did. But that's pure, absolutely gambling. And you're in the right place at the right time. And a lot of people lost everything. So be careful. Be careful with these kind of ideas out there as a smart decision maker. Okay, so computer actually has two things, a program and a data, as I started my discussion. So programs do what? Programs do what?
Process.
They solve problems. They process something. They process data into information. That's what the program does. So you need both. My bias is data is more critical. At the same time, you cannot process the data if you don't have a smart program. So you need a smart and efficient program to process the data into useful information. Why do you need useful information? So decision makers can make better decisions. So some of the languages we use to process data, and these are high-level languages. You might have heard some of them. And did I show you the chart last time? Yeah. Fortran, the first one, and on and on. So you can see that these are some of the major languages. Some of these languages are specific, like Ada is. Ada was. Anybody knows why we have this name, Ada?
First programmer?
She was the first ever programmer. It was a lady. And she was one of the students of Babbage. Babbage was one of the scientists who developed first ever computer, a mechanical computer. So that computer didn't function fully in his lifetime, but after that, that analytical engine worked, and that is considered as one of the. So he has a name in the history. So Ada Lovelace is considered as one of the greatest because she was one of the first developers. In fact, you look at the older 1940s and 50s and 60s pictures, especially 40s and 50s, you'll see a lot of women operating these mainframe computers at that time. So something happened in 90s and late 80s and early 90s that we discarded this large population segment from technology. So now we have very few women in technology. In fact, I was working on one of the grants from our college. The grant was $25 million from National Science Foundation just to study and understand why there's a 80% drop in computer science graduation in 10 years and 90% drop in graduation for women and minorities, Hispanics and African American. So not too many people are interested in technology, especially I mentioned women. So if you are a woman, you're interested in technology, start a club here. Start Women in Technology. Many of the other colleges have already started, and they actually have hired specialized diversity directors or vice presidents to hire more women in technology. So you actually have a higher chance to get into technology area because they're looking for those individuals. They're looking for a woman doing bachelor's in computer science. They will give you priority. I'm not sure some men will get upset or not, but they will give you priority because they want more women to come in and add value to computer programming. So coming back to this one, I have worked in 7 or 8 of them: C, C++, Java, Pascal, Visual Basic, Fortran, C#, Python. I know a little bit about PHP, but I have not worked on PHP. I've worked on assembly. I worked on, there used to be COBOL and BASIC and JCL and SQL, all sorts of other things, HTML, XHTML, and a few other ones as well. So these high-level languages resemble human languages. So if you draw a human language, and I think I showed you the hierarchy last time. Machine language is here, human language is here. So that's how you can actually make it easier for humans to write that code. Yeah.
So all these languages, they started in the 1960s?
No, so this, like Fortran was the first ever high-level language. It was started in 1954, but they continue to evolve. So after a couple of years, 3 years, you'll see a new edition after modifications. So even, I think the last modification for C++ was, I think, 2011. Now it's called C++ 11, I believe. So you'll see there are additions, just like any other changes into other software as well.
How do they start?
You can start a programming language.
Oh, okay.
You can start a programming language. You can use, if you feel that your industry, let's say you're working in, let's say manufacturing industry, or you're working in forestry, and you feel that there are no real systems available in your particular industry, so you and like-minded people can start something small, and then you can make it open or public domain. A lot of people will add methods and functions, and it will become and emerge as a fully functional language. That's how many of the languages started. So, and you need to have a problem first in hand. What is the problem? Problem is smartphone and security of the smartphone. So you can actually come up with there's a newer language called R language. I know Dan and a couple of other, I think Elizabeth, she mentioned, Elizabeth, right? Actuarian that you want to be. So there is a R language, which is statistical analysis language. So if you want to get into that kind of area, there's a language available. Like ADA language is only for defense industry. Fortran, Formula Translator, is for scientific community. So there are some languages specific to certain things. PHP, these languages are for web development and those kind of things. So these high-level languages are easier to read and write, and you can actually write complicated code. We will gradually, hopefully in 6 weeks. Hopefully we'll have a lot of open seats by that time. You'll see, already we have a lot of open seats. I always like to scare the first week. So if you don't have a strong heart, you do not come next week. So I was successful. So I'm going to scare you a little bit more. So if you're strong, brave, then we'll actually have our journey. must be translated to, in fact, the language you are going to write will be a source code. So our language will have an extension of .cpp, and then it will be converted into object code or .obj, object code. From .object code, you will convert into .exe. And we'll see how it works. Anybody can tell me what program converts the source code into object code? Compiler. Yeah, so you have a program. This will be a good exam question. A compiler is a program which converts your source code into object code. Your object code is binary code. Object code is in ones and zeros. But object code itself cannot run independently. It needs some helping libraries. It needs some linked libraries. So those libraries are linked, then becomes independent code, then it's converted into executable file. So you can actually take an executable file, you can run it independently. You can put it in the browser, you can put it in a smartphone, and it runs independently. Like when I teach app development class, the first day of the class, the students write the code, they actually send it to their smartphones, they download, install, and it works. Takes less than an hour, and you write your first app on Android phone. Really, really simple. It's mind-boggling how easy it is. Now, that doesn't mean that you're going to make a lot of money. You need to have specific target market segment or specific need that people are looking for that kind of app. Because there are a lot of apps already available for whatever you do. For example, weight loss, or for example, diets, and there are a lot of apps available. So this is what you want to keep in mind, that you'll be writing source code, and we'll be doing that after the break as well. Okay, so assembly language has some reserved words. We call them add, subtract, multiply, store. There are very few of them. But still, it's cumbersome to write. Assembly language is considered as low-level language. Some of you will be required to take an assembly language. It's not a punishment. It's a good thing that you can write most efficient code. Assembly is the most efficient way to write the code, especially if you're writing a code for chip design, chip manufacturing, and those kind of things, which requires very high level of efficiency. On the other hand, the high-level languages such as C++ will be writing a code which will look like our human language, which will be converted into ones and zeros or object code. So then linker links the libraries. So initially we'll use one library, IOStream, input-output stream, and then a couple of weeks we'll be using a couple of them. We'll be using IO manipulator, math library, string library, and a lot of other libraries. So gradually be adding more and more libraries. So this is what the linker does. Object is available for us to use. However, it needs some help from linker. So we write an object code for the precompiled routines into the machine language. It's not very clear here, but that's what linker does. Linker basically adds the library code into your source code, and it's converted into your object code, and it's converted into your executable code. So Charles Babbage, I already mentioned that one. So he didn't complete his analytical engine. And as you can see, Ada Augusta Lovelace, she was a colleague / student of Babbage, and she actually has the name in the history, and we still are using a language under her name. So these will be probably in your exam. So that's why it's asking you 5 main components of a computer, list the data for a program that adds 2 numbers, describe what is a compiler, what is a source code. You have to know what is a source code. So when you want to say my program, you can say my source code. So then you convert the source code by compiling it. So that will be your object code. Okay. So a couple of more things, and we'll start. Anybody has a time? What time do we have? 7:20. So let's spend maybe 15-20 more minutes. Then we'll take a break. I know some of you are kind of exhausted, worked all day. But this chapter is very dry and it has a lot of concepts. The other chapters will be more interactive. So I really want you to use this term all the time because you will sound smarter and you might get a job as well. Put it in your resume, put it in your LinkedIn account, put it somewhere. Use this extensively. This is the term which is very popular these days. Very popular. And this term means a sequence of precise instructions that leads to a solution. Now, algorithm doesn't need to be in a computer system. Algorithm could be you're trying to figure it out, very specific instructions or method to graduate in 4 years. So you have step-by-step instructions and you know exactly this month you're going to do this semester you will be doing this is your grade and all those things. You have written down every single thing. That will be your algorithm. Do you think that's really possible? You write down everything and it will happen? It happened to me. I actually had written down every single step before I started my undergrad program.
Well, the programs are proof of that, right? All the applications that are written.
Yes. I actually had right above my bed. I looked at it every single day. I checked things every month, every semester. And normally people take, again, I'm not exaggerating, but you can actually write down an algorithm, precise algorithm. Sometimes you fail, and that's true in programming as well. Your program will fail, and that's how you learn. You're going to improve your program. But your job as a problem solver, because you're trying to be a problem solver, is to write good algorithm. So if somebody you see on the street and you say, you know what, I can grab a nose from here. And they try and they break their arm. Or then you find another guy, he's walking around, maybe no shirt on, and he says, I can grab my nose from here. You're not going to follow those people. You're going to say, you know what, I can grab my nose from this side. And you still look pretty not smart. But the best algorithm would be, you step by step describe, you grab your nose just like this one. This is the most efficient way to write the code. So that's exactly what you're going to do when you have a very large problem. You want to divide and conquer each one of those sub-problems. So your big problem is finish your school in 4 years. Divide and conquer. Divide by semester. Divide by a month. Divide by a week. Divide by a day. So if you do that, you'll be able to accomplish that one. So that as a developer, that's how you develop the left side of your brain. You become very methodical, very refined in your thinking, extremely focused. Now, some of you are already like that. Some of you have to develop that skill. It can be learned. It can be learned. But once you have that skill, just to give you an idea, we have Canvas. Canvas is required now starting this semester, all of the Santana College. So they have different levels of expertise. They have bronze badge, bronze certification, silver certification, gold certification. And it takes a long time to finish all 3 certifications. Certification means that basically you know how to add certain things, how to remove certain things, where everything is on Canvas. So somebody sent me a message, actually our dean sent me a message that if you're interested in teaching online section, you have to be certified in Canvas. I said, I've been teaching online classes for 12 years. She said, no, still it's required in Santana College. I said, okay. So it took me 3 or 4 hours to do all 3 certifications. For other instructors, it will take them a month or so because it's an overwhelming experience for them. Instead of taking the first step, have the clarity in their thought, they will be overwhelmed. Oh, it's going to take so long. And it literally takes them a month or so for some couple of weeks. But you can do it. So when I started my PhD, I finished in 2 years and 9 months. Other people, my colleagues, it took them 7 years. 7 years the maximum. So 6 years, 7 years. You can do it if you have the algorithm in your hand. You can think like a developer. Think like those programmers, that you have deadlines, you have to reach those deadlines. I'm not exaggerating about myself. I'm just saying that as a developer, you have to develop that mindset. You have to have a focus, and clarity, and you have to have the deadlines. And you have to write it down. You have to put it on a piece of paper or on some kind of technology. So it's an algorithm expressed in a language, in C++ language in our case, so computer can understand and we can solve that problem. So that will be your program. That will be a precise definition for the program. So it's no complete set of rules for creating a program. Result is an algorithm that solves the problem. Implementation. So there are different phases. Some places there will be 6 phases. Some places there will be 5 phases. Phases are like plan, analyze, design, develop, implement, maintain. There are 6 phases. I'm going to repeat them. So you plan, you analyze, you design, develop, implement, and maintain. These are the 6 phases. This is called SDLC, System Development Lifecycle. So this is one of the methodology in information systems when you're implementing larger and complex systems. If your system is smaller, like all you're doing is your app is supposed to say hello. Doesn't require all those steps involved. But if you're implementing Obamacare, for example, Access California, for example, or something much more complex, then you have to go through these phases. So in implementation phase, result is algorithm translated into programming language. And if implementation phase does not provide you the desired results, you can always go back. So what is the input you need to know? What is the information? How's the output organized? Develop the algorithm. It saves time to run your program and test and retest over and over again. In fact, many of the major tests, especially done by our defense industry, each test can cost $100 million. When they test new missile, one missile is, we had a threat from North Korea, so they were testing missiles. Like, what if they have a ballistic missile? How do you catch that missile? That kind of test costs them $100 million. So some tests are very expensive. So some other tests might not be that expensive, but so you will be going through those kind of understanding when you're working in a large company. So those tests you have to be very careful because you have a role to play. Some of you will become testers, the quality assurance individuals. So you'll be testing systems. Some of you will become developers. Some of you will become implementers. Some of you will become trainers. So you'll have different roles to play. To run the program in sample data, results might require some modifications in your algorithm. Like I said, you will probably go back. I think I'm going to stop here. I'll pick it up from object-oriented when I come back. What I want to do is, again, if you came late, I wanted to discuss half of the chapter, which I already did. So I'm going to pick up the rest of the chapter next Tuesday. And I would like to start Visual Studio together. So we'll actually work together. We'll actually set up our first project together. We'll be discussing this project, which is due on Sunday. So some of you, anybody has already submitted? I think 1 or 2 individuals already submitted. I think that's why you're not here. So, okay, raise your hand if you're not here. All right, so what we'll do, we'll take a break and we'll come back. Thank you very much. See you soon.